So let's do one example, start to finish. In your notes it says, photosynthesis is an endothermic reaction which absorbs 2,802.5 kilojoules of energy. Express this 4 ways and express the molar enthalpy for carbon dioxide. So first I'm going to start by just refreshing the reaction for photosynthesis. So I know I have 6 carbon dioxides combines with 6 water molecules to form C6H6O6. Oh, not H12. What am I doing? C6H12O6 and 6 oxygen. So there's my overall reaction plus the energy they've given me in the equation. So number 1, I want to write that as a molar enthalpy symbol. This isn't a combustion, it's not a formation, it's not a decomposition. It doesn't really fit those types. So I'm just going to call this delta RHM. And they want it per molar enthalpy here of carbon dioxide. So if I look at this equation and I see that it's the 2,802.5 kilojoules of energy for this total equation, how much is it per 1 mole of carbon dioxide? I get the 2,802 for 6 moles of carbon dioxide in that balanced equation. So that means in order to get it down to 1 mole, I have to divide by the number of moles. Let me just show this real quick. Remember your formula delta H is equal to N delta HM. So they've given me the delta H, 2802.5. The number of moles here is 6. Delta HM is what I want. So I'm going to end up dividing this by 6 to get to the delta HM, which for many of you probably made sense without even having to do that. Actually, I didn't want to erase all that. I just wanted to erase this. So in your head, that might make sense. You don't have to use the formula. If that's the case, don't worry about it. But if that helps, go for it. So in this case, it's not the 2,802.5 kilojoules. It's 467.1 kilojoules per mole. But I also have to say whether this is endo or exothermic. And it tells me it's an endothermic reaction. So I'm going to put the positive. I know in math, a lot of times you don't write +1. You just write 1. I like to write positive here because that just tells me when I look at my work, I did think about it and I decided, I consciously made a decision that's endothermic. So I'm good. All right, so there's the first one. Second one is, what if we put it into delta H notation? So I've got my balanced equation already there. I'm just going to copy that down again. But in delta H notation, we put to the right of the equation delta H equals with that value. And since I've balanced this for the same reaction we started with all 6 moles of carbon dioxide, then this is the positive 2802.5. Come on, get in there. There we go. Little messy, but at least it's in there. 2802.5 kilojoules. The next one is if I put it into the equation. So remember, this is an endothermic reaction. So the energy should go on the reactant side. So I have 6 CO2, 6 water, plus 2802.5 kilojoules becomes C6H12O6 plus 6O2. There's my equation with it punched in. Same information. Remember that those two numbers for number 2 and number 3, they both have to balance how you, or have to match how you've balanced, but in this case it all works out. And then fourth, if I was to write this as a diagram, remember to draw this out and label it. So this is potential energy. This is my reaction coordinate. I'm just going to simplify it there. It's endothermic, which means it should be gaining energy So this graph should go like this, start low and then high. This is 6 CO2, 6 H2O, C6H12O6 plus 6O2. And then next to this vertical, I would write delta H equals a positive 2802.5 kilojoules. All of those four right here tell you exactly the same information. They have some way of telling you what the reaction is that's taking place and how much energy, how much energy for one, and two, whether it's exo or endothermic for a reaction by looking at that. So hopefully you're familiar, you're getting comfortable with the idea. It's going to take some practice, so that's why you got your notes. To get you used to the balancing, read the questions carefully. Some of them will want you to change it to delta H notation or some into putting it in the equation, but some of them will also tell you how they want you to balance. So they'll say use fractions or use no fractions. Make sure everything's a whole number. So you're going to have to make those little adjustments. Just watch for those in the questions and make sure your delta H always matches how you balanced the equation. The delta HM doesn't matter. That one's universal, like the kilometers per hour or miles per gallon. That one will be the same, but delta H is always change depending on how you balance. So go ahead, give those a try. I'll make sure I put the work up on the website so that you can see and check as you go. If you have any trouble at all as you're moving through these, just let me know. We'll work through it together.